Imagine a world where death is not the end, where the limitations of our biological bodies are a relic of the past, and where humans can live indefinitely. This is the tantalizing concept of immortality, a dream that has captivated the minds of scientists, philosophers, and futurists for centuries. In the year 2055, humanity stands on the brink of an unprecedented era. Through technological marvels and groundbreaking discoveries, we have unlocked the secret to eternal life. But how did we get here? And what does this mean for the future of our species? From the dawn of civilization, humans have sought ways to transcend death. Ancient myths and legends are filled with stories of gods, heroes, and alchemists searching for the elixir of life, the fountain of youth, or magical artifacts that grant immortality. These tales reflect a deep-seated desire to overcome our mortal limitations. In ancient Egypt, pharaohs were mummified and buried with treasures, food, and even servants to accompany them into the next world. They believed that through these elaborate rituals, they could achieve a form of eternal life. In China, the first emperor, Qin Shi Huang, sent out expeditions in search of the elixir of life. Ironically, his quest led him to consume mercury pills, hastening his death instead. The search for the philosopher's stone by alchemists in medieval Europe is another testament to humanity's relentless pursuit of eternal life. Cultural stories from around the world feature immortals and gods who live forever. The Greek gods on Mount Olympus, the Hindu gods who reincarnate and live through endless cycles of time, and the Norse gods who prepare for Ragnarok all reflect our fascination with transcending mortality. Today, the quest for immortality has moved from the realm of myth to the laboratories of scientists and researchers. Advances in medicine, biology, and technology have brought us closer than ever to the possibility of extending human life indefinitely. The study of aging, or gerontology, seeks to understand the biological processes that cause our bodies to deteriorate over time. Researchers are identifying the key factors that contribute to aging and developing interventions to slow down or reverse these processes. Regenerative medicine aims to replace or regenerate human cells, tissues, or organs to restore normal function. Techniques like stem cell therapy and tissue engineering are already making significant strides. Imagine a future where damaged organs can be regrown or replaced entirely, extending our lives by decades. The advent of CRISPR and other gene editing technologies allows scientists to modify the human genome with unprecedented precision. By targeting and repairing genetic defects, we could potentially eliminate inherited diseases and significantly extend our lifespan. One approach to achieving immortality is to slow down or even reverse the aging process itself. Senescent cells are damaged cells that have stopped dividing but don't die. They accumulate in our bodies as we age, contributing to inflammation and various age-related diseases. Researchers are developing senolytics, drugs that selectively eliminate these cells. Early studies in animals have shown that removing senescent cells can improve health and extend lifespan. Telomeres are the protective caps on the ends of our chromosomes that shorten each time a cell divides. When they become too short, the cell can no longer divide and becomes senescent. Techniques to lengthen telomeres could rejuvenate cells, effectively reversing some aspects of aging. Researchers are exploring ways to activate the enzyme telomerase, which can extend telomeres and potentially increase lifespan. Studies have shown that reducing calorie intake without malnutrition can extend lifespan in various species, from worms to monkeys. The exact mechanism isn't fully understood, but it's believed that caloric restriction triggers a survival response that promotes cellular repair and maintenance. While it's not a practical solution for everyone, it has inspired research into developing drugs that mimic the effects of caloric restriction. Another fascinating avenue is the concept of mind uploading, transferring human consciousness to a digital medium. The human brain is the most complex organ, with approximately 86 billion neurons, and trillions of connections. Mapping the brain's neural connections, known as the connectomy, is a monumental task. Advanced imaging technologies and machine learning are helping scientists understand the intricate network of neurons, bringing us closer to replicating the brain in a digital format. Once we have a detailed map of the brain, the next step is to create a digital simulation. This involves replicating the structure and function of each neuron and synapse in a computer model. Theoretically, if we can simulate the entire brain accurately, we could transfer a person's consciousness to this digital format, achieving a form of digital immortality. The complexity of the brain presents significant technical challenges. Replicating the brain's vast network in a computer model requires immense computational power. Moreover, there's the philosophical question of whether a digital copy of a person is truly the same person. Ethical considerations also arise. Who gets to decide if and when a mind is uploaded? Could this technology be misused? Nanotechnology offers another route to potentially achieve immortality by repairing and maintaining the body at a cellular level. Imagine tiny robots, smaller than a human cell, patrolling your bloodstream, repairing damage, and eliminating diseases. These nanobots could be programmed to perform precise tasks, such as targeting and destroying cancer cells or repairing damaged tissues. Researchers are already developing prototypes and exploring the potential medical applications of nanobots. The potential applications of nanotechnology in medicine are vast. Targeted drug delivery systems could ensure that medications reach the exact location needed, reducing side effects and improving efficacy. Nanobots could also perform complex surgeries at the cellular level, repairing organs and tissues without invasive procedures. Recent breakthroughs have brought us tantalizingly close to significant extensions of human lifespan. Senolytics, drugs that selectively eliminate senescent cells, have shown promising results in animal studies. Mice treated with senolytics have exhibited improved health, increased lifespan, and even rejuvenation of certain tissues. Clinical trials in humans are underway, and early results are encouraging. CRISPR, the revolutionary gene editing technology, has made headlines with its ability to precisely edit the human genome. Recent advancements have demonstrated the potential to eliminate genetic diseases, repair damaged DNA, and even extend lifespan. The possibilities are vast, and researchers are just beginning to explore the full potential of CRISPR. Advances in 3D printing have led to the creation of artificial organs and tissues. Researchers are now able to print functional organs, such as kidneys and hearts, that can be transplanted into patients. This breakthrough could solve the problem of organ shortages and significantly extend the lives of those with failing organs. As we delve deeper into the quest for immortality, one cannot overlook the remarkable potential of cloning. Cloning, once a concept relegated to the realm of science fiction, has evolved into a powerful scientific tool with profound implications for extending human life and achieving immortality. Cloning involves creating an identical copy of an organism, cell, or piece of genetic material. The most famous example is Dolly the sheep, cloned in 1996 by scientists at the Roslin Institute in Scotland. Dolly was the first mammal cloned from an adult somatic cell using a technique called somatic cell nuclear transfer, SCNT. This breakthrough demonstrated that it was possible to create a genetically identical organism from a single cell, opening the door to new possibilities in medicine and biology. Therapeutic cloning, also known as somatic cell nuclear transfer, SCNT, is a technique that involves creating embryonic stem cells genetically identical to a donor organism. These stem cells can differentiate into any cell type, making them invaluable for regenerative medicine. By generating patient-specific cells, therapeutic cloning could revolutionize the treatment of diseases and injuries, allowing for the repair or replacement of damaged tissues and organs. Imagine a future where organs damaged by disease or injury can be replaced with cloned organs grown from the patient's own cells, eliminating the risk of rejection and the need for lifelong immunosuppressive drugs. This could significantly extend the lifespan of individuals with chronic diseases or those in need of organ transplants. Reproductive cloning aims to create a genetic duplicate of an entire organism. While this concept raises numerous ethical and moral questions, its potential implications for achieving immortality are significant. If we can clone humans, theoretically, we could create a genetically identical copy of an individual, providing a form of biological immortality by creating clones to serve as repositories for organ transplants. However, reproductive cloning is fraught with ethical dilemmas and technical challenges. Cloning a human being involves not just replicating their genetic material, but also ensuring the cloned individual develops normally and healthily. Moreover, there are questions about identity, individuality, and the societal implications of cloning humans. Such practices raise significant ethical questions about the rights and status of the cloned individual. One of the most promising aspects of cloning in the context of immortality is its potential for cellular rejuvenation. As we age, our cells accumulate damage and lose their ability to function optimally. Cloning technologies, combined with advances in genetic engineering and regenerative medicine, could rejuvenate aging cells, effectively turning back the biological clock. Researchers have discovered that the process of nuclear transfer can rejuvenate aged cells. By transferring the nucleus of an aged cell into an enucleated egg cell, scientists can create embryonic stem cells with youthful properties. These rejuvenated cells could then be used to regenerate tissues and organs, potentially reversing the effects of aging. A significant breakthrough in cloning technology came with the discovery of induced pluripotent stem cells, iPSCs. By reprogramming adult somatic cells to an embryonic-like state, scientists can create pluripotent stem cells capable of differentiating into any cell type. This technique offers a less controversial and ethically fraught alternative to embryonic stem cells. iPSCs hold immense potential for regenerative medicine. By creating patient-specific iPSCs, researchers can generate healthy, youthful cells to replace aged or damaged ones. This could lead to treatments that not only extend lifespan, but also enhance the quality of life by maintaining youthful, healthy tissues and organs. Cloning also opens the door to genetic enhancement, a controversial but potentially transformative avenue in the quest for immortality. By combining cloning with gene-editing technologies like CRISPR, scientists could create genetically enhanced humans with superior health and longevity traits. For example, clones could be engineered to have enhanced resistance to diseases, slower aging processes, or even improved cognitive abilities. While the ethical implications of such enhancements are complex, the potential benefits for human health and longevity are immense. Another critical aspect of cloning and cellular rejuvenation involves telomeres, the protective caps on the ends of chromosomes that shorten with each cell division. When telomeres become too short, cells enter a state of senescence or die. By using cloning techniques to reset the biological age of cells, we can extend telomeres, promoting cellular health and longevity. Research into telomere extension through cloning and genetic engineering is still in its early stages, but the potential is undeniable. If we can maintain or even lengthen telomeres in human cells, we could significantly delay the aging process and extend the healthy human lifespan. The potential of cloning to achieve immortality is accompanied by significant ethical considerations and societal impacts. The idea of cloning humans raises questions about identity, individuality, and the nature of personhood. Would a clone be considered the same person as the original, or a separate individual with their own identity and consciousness? There are also concerns about the potential for abuse and inequality. If cloning technologies are only accessible to the wealthy and powerful, it could exacerbate existing social inequalities and create new forms of discrimination. Ensuring that these technologies are used ethically and equitably will be one of the greatest challenges as we move towards a future where cloning could play a central role in achieving immortality. To address these challenges, robust regulatory and ethical frameworks are essential. Scientists, ethicists, and policymakers must work together to establish guidelines that ensure the responsible development and application of cloning technologies. This includes addressing issues such as consent, the rights of clones, and the potential long-term impacts on society. Public perception and acceptance of cloning will also play a critical role in its development and application. Education and transparent communication about the benefits, risks, and ethical considerations of cloning are crucial. Engaging the public in discussions about the future of cloning and its potential role in achieving immortality will help build trust and foster informed decision-making. The year is 2155, a century after humanity first unlocked the secret to immortality. The groundbreaking discoveries of the mid-21st century have reshaped society in ways previously unimaginable. The average human lifespan has increased dramatically, with many individuals living well beyond 100 years in perfect health. The world has changed in profound and unimaginable ways, shaped by the technologies and discoveries that have allowed humans to transcend their biological limitations. This chapter takes us on a journey through a day in the life of this future world, exploring how society, culture, and individuals have adapted to the reality of eternal life. In the bustling metropolis of New Avalon, a city built on the foundations of advanced technology and scientific innovation, life in 2155 is a blend of the familiar and the extraordinary. The cityscape is a testament to human ingenuity, with towering skyscrapers, green spaces, and advanced infrastructure designed to accommodate a population that no longer ages or dies. Each morning, citizens of New Avalon begin their day with the ritual of renewal, a routine that has replaced traditional healthcare practices. This involves a visit to a local rejuvenation center, where advanced regenerative treatments and nanotechnologies ensure their bodies remain in peak condition. These centers use a combination of stem cell therapy, genetic engineering, and nanobots to repair any cellular damage, maintain organ health, and rejuvenate tissues. In these centers, individuals also undergo periodic updates to their digital backups. Mind-uploading technology has advanced to the point where people can create regular snapshots of their consciousness. These backups ensure that in the event of a catastrophic accident, their memories and personality can be restored in a new body. The workday in 2155 is vastly different from what we know today. With the elimination of aging and disease, people are free to pursue careers and passions without the constraints of time. Many individuals engage in multiple professions throughout their lives, constantly learning and evolving. Education is a lifelong endeavor, with citizens regularly attending advanced courses and workshops to acquire new skills and knowledge. The economy of 2155 is driven by innovation and creativity. With basic needs such as food, housing, and healthcare provided by automated systems and artificial intelligence, people focus on advancing science, technology, and the arts. The quest for knowledge and self-improvement is a central aspect of life, as individuals seek to make meaningful contributions to society. With extended lifespans, humans have ventured beyond Earth, exploring and colonizing other planets. Interstellar travel, once a distant dream, is now a reality. Spaceports in New Avalon are bustling with activity as people embark on journeys to distant worlds, participating in scientific missions, and establishing new colonies. In addition to physical exploration, the digital realm offers infinite possibilities. Virtual reality and augmented reality technologies have created immersive worlds where people can experience anything imaginable. From historical reenactments to fantastical adventures, these digital environments provide endless opportunities for exploration and entertainment. As the day comes to a close, citizens of New Avalon gather with friends and family to share their experiences and reflect on their journeys. The concept of family has evolved, with people forming deep, enduring connections that transcend biological ties. Communities are built on shared interests and values, fostering a sense of belonging and purpose. The arts have flourished in this age of immortality. With unlimited time to hone their craft, artists, musicians, and writers create masterpieces that push the boundaries of human expression. Cultural events and performances are a central part of daily life, bringing people together to celebrate creativity and innovation. As night falls, the city of New Avalon illuminates with the glow of advanced technologies. People retire to their homes, which are equipped with intelligent systems that cater to their every need. Homes in 2155 are not just places to live, but hubs of innovation, with advanced labs and workshops for personal projects. Before drifting into a state of restful slumber, individuals often engage in deep meditation and mindfulness practices. These practices have been enhanced with neurofeedback technologies, allowing people to achieve profound states of consciousness and self-awareness. The night is a time for introspection and planning for the future, as individuals dream of new adventures and discoveries. The advent of immortality has transformed society in ways that were once unimaginable. While the benefits are profound, this new era has also brought challenges and complexities that humanity continues to navigate. One of the most significant challenges of immortality is managing population growth. With people no longer dying, cities like New Avalon have had to innovate to accommodate increasing numbers. Vertical farms, floating cities, and sustainable living practices have become essential to support the growing population. In the face of escalating population density, New Avalon pioneered the concept of vertical farming. These towering agricultural structures, integrated into urban landscapes, produce vast amounts of food within city limits. By using advanced hydroponics and aeroponics, vertical farms maximize space efficiency, reduce transportation costs, and minimize the environmental impact of food production. Crops grow year-round under controlled conditions, ensuring a stable and abundant food supply for the ever-increasing population. Floating cities have also emerged as a viable solution to land scarcity. Constructed on buoyant platforms, these cities expand living space onto oceans and large lakes. They feature self-sustaining ecosystems, complete with renewable energy sources, waste recycling systems, and desalination plants. Floating cities not only alleviate urban crowding, but also represent humanity's adaptation to rising sea levels caused by climate change. The century of immortality has seen astonishing technological advancements. Nanotechnology and artificial intelligence have revolutionized healthcare, with nanobots routinely used to monitor and repair the human body at the cellular level. AI-driven diagnostic tools and personalized medicine have made diseases and medical conditions virtually non-existent. Interstellar travel, once a distant dream, has become a reality. With extended lifespans, humans can embark on multi-generational space missions, exploring and colonizing distant planets. Space travel has opened up new frontiers for humanity, ensuring the survival and expansion of our species beyond Earth. Sustainable living practices have become the norm in the era of immortality. Urban planners and architects design cities with green spaces, energy-efficient buildings, and integrated public transportation systems. Smart grids manage energy consumption, utilizing renewable sources like solar, wind, and geothermal power. Waste is minimized through comprehensive recycling programs and the use of biodegradable materials. In residential areas, homes are equipped with smart technologies that optimize energy use, reduce water consumption, and monitor environmental impact. Community gardens, rooftop farms, and urban beekeeping contribute to local food production and enhance biodiversity within city environments. To prevent overpopulation, governments have implemented strict population control measures. Birth rates are regulated through policies that limit the number of children per family. Incentives for voluntary childlessness and adoption programs have also been introduced to manage population growth responsibly. These measures ensure that the benefits of immortality do not lead to unsustainable population levels. Advanced reproductive technologies offer alternatives to traditional childbirth. Artificial wombs, genetic screening, and in vitro fertilization allow for planned and controlled population growth. These technologies help maintain genetic diversity and prevent overburdening the planet's resources. With immortality, societal structures have evolved to accommodate the new demographic reality. The concept of aging has transformed, with age-related milestones becoming less relevant. Instead, life stages are defined by personal achievements, career shifts, and continuous learning. Employment practices have adapted to the extended lifespan, allowing individuals to pursue multiple careers and take sabbaticals for personal growth. Retirement, as it was known, has become obsolete. Instead, people transition through various phases of work, education, and leisure throughout their lives. In an immortal society, intergenerational relationships have taken on new significance. Families often span several generations, with great-great-grandparents interacting with their descendants. These extended family networks provide a strong support system and a rich tapestry of shared experiences and wisdom. Education systems have evolved to address the needs of lifelong learners. Schools and universities offer flexible programs that cater to different life stages, encouraging continuous personal and professional development. Mentorship and apprenticeship programs facilitate knowledge transfer between generations, fostering innovation and preserving cultural heritage. Cultural norms and values have shifted in response to immortality. The traditional focus on youth and beauty has diminished, replaced by an appreciation for wisdom, experience, and continuous self-improvement. Art, literature, and entertainment reflect the diverse experiences of an immortal population, exploring themes of eternity, identity, and the human condition. Social institutions, such as marriage and family, have also adapted. With lifespans extending indefinitely, relationships evolve over time, and societal acceptance of diverse family structures has increased. Long-term partnerships may include periods of separation and reunion, reflecting the fluid nature of relationships in an immortal world. The challenges of immortality have necessitated unprecedented global collaboration. International organizations and alliances have formed to address issues such as resource distribution, environmental conservation, and ethical considerations surrounding immortality technologies. Shared governance models ensure that the benefits of immortality are distributed equitably and sustainably. Global cooperation extends to scientific research and technological development. Collaborative efforts in fields like medicine, genetics, and environmental science drive innovation and address the complex challenges of an immortal society. Knowledge and resources are shared across borders, fostering a spirit of unity and collective progress. The quest for immortality is one of humanity's most ambitious and profound endeavors. Whether through biological longevity, digital consciousness, nanotechnology, cloning, or other groundbreaking technologies, the dream of eternal life drives us to push the boundaries of science and technology. While the journey is fraught with challenges and ethical dilemmas, the potential rewards are beyond imagination. As we stand on the threshold of a new era, we must navigate the complex landscape of immortality with wisdom and compassion. The decisions we make today will shape the future of our species for centuries to come. What do you think about the quest for immortality? Are you excited about the possibilities, or do you have concerns about the implications? Share your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon for more fascinating explorations into the future of humanity.